Hello students, in this lecture we are going to learn about genetic programming. Already we have seen what is genetic algorithm, which was designed by John Holland. Like GA, that is genetic algorithm, GP is an programming where you will convert all the operators such as reproduction, crossover, mutation, fitness into programming language. So these are encoded as individuals or population of encoded programs. So this is called as genetic programming. So the genetic programming representation can be done as a tree based. Okay, so it will show in the tree based representation where we can use all the functional languages like Lisp and Lisp expressions. So for example, so complete genetic programming representation will be in the form of the tree and Lisp. So what is meant by Lisp? Yeah, if you see an example here, so here if A is less than B, in this one example, A is less than B, then A equal to A plus 1, else B equal to B into B. C equal to A into B into 2, and so same thing in the Lisp equivalent. So what we are doing, prog n, if A less than B, set Q A equal to A plus A1. So this is 1, A plus 1. Set B equal to B into B. Or if this is not equal, again I am going for set C equal to this one, A into B into 2. So this particular complete if part in the Lisp can be written like this. Okay, so our genetic algorithms will use the Lisp equivalent programming rather than normal algorithm language, what we are used in our traditional programming language. So this is a programming tree, what we have seen, prog n, if, set q. So if A is less than B, set q, A plus 1, okay, A equal to A plus 1 and B equal to B into B. So like that. Similarly, set q. So what we are doing, first we are going for A into B, again B into C, and C as B into 2, and this is your C. Yeah, if you see here, A into B into 2. So A into B into 2 equal to C. So you are setting Q, C. So this is a tree representation, and this is a Lisp representation of genetic programming. So what is a simple program fragment? So this consists of all the functions. The interior nodes of the tree consist of the functions, and leaf node consists of the terminals. So here prog n is the function, if is also function, set q is also function, and less than is also function, and here C and star also function. Only leaf nodes will be our terminals, that is values. Now terminals will include the constant and variables. And terminals from the leaves of the tree are always additive of 0, that is, it will have only 0. That is, cardinality will be 0. And we have to require to use the set of terminals and functions. For example, if we are using logical and or not, the terminals will be x1 and x2. And two Boolean variables. So this particular function will be XOR. Okay, for example, in the tree, if I'm using XOR, this will be your XOR. And this will be result, and you'll have the variables over here. So this will be XOR, these are the variables. Okay. So if I see if A less than B, so I'll write here XOR operator and A XOR B. So that is our thing, what I want to tell you here. Now, genetic operators in algorithms, already we have seen fitness, proportional reproduction. So according to the fitness, we are going to select the population from the given set of values. So it will be from Darwinian selection analogous, that is survival of the fittest. Who is fittest one, that will be used. Second one is Roulette wheel, that will go for the probable one, and tournament selections. So it will take some probable or random variables, and from that they will check. And tournament selection also similar to that. So it is roughly analogous, and a small group of individuals. Tournament selection will be used for only small list of individuals, and the fitness will be on win of the tournament. Suppose I'll create one competition between the set of the population. So who is winning that particular tournament, he will get the chance to be selected, and he will considered as the fittest one. And crossover, after getting the two parent programs, will go for the mating them. So first a random node. Okay, I'll show one example here. So these are the two, parent 1 and parent 2. Then I'll create an offspring between these two. Okay. So this is for plus of plus AB, A minus 2. So this is for this one. And into star of plus 5AB. Okay, so 5 plus A and you are taking B. So from these two, I am creating an offspring. Okay, so I am cutting this particular edge. If you see here, only is B here and remaining minus A2. These two are same. Okay, so I am cutting this particular edge. If you take here, what I am doing, I am cutting this particular edge. Okay, so I am adding the part of this part, that is plus AB. So I am adding over here. So this is 5A is as it is, and whatever I cut from this particular edge will be added over here. Got it? So what we have done here, offspring, this is from parent 1. I remove this particular A over, and this is your just plus B. So I am removing this particular B, and this is as it is. And what I have done here, complete this particular edge I have added over here. So this is offspring 2. So this is called as crossover. So where you can add or you can delete or you can select the node and do it. Finally, mutation. After selecting this one, mutation, if it is not working properly, I will change some part. So I in this example, original was this. So I am cutting this particular thing. Then what we are doing, I am adding this particular part, this one. So mutate means these two are combined in order to get complete tree. So here I am cutting this particular edge. I am adding new random subtree. I can add any subtree, and in the mutated I am doing this. When I do, if this particular original is not performing the required task. So this is called as mutation. So what is meant by closure? So closure, suppose improbable, if it is improbable. So the problem is addressed by property called closure when produced evaluating function or terminal can be augment to another. Okay, I'll tell you the example. Closure means if I'm doing one problem and the output of that particular function will be input to the next one. Okay, so for example, yeah. So if I'm doing this part, okay, in this example, the output of this particular 4, okay, 4AB into 3. So this is input to this particular function. So if these two functions are not properly organized, so then it will create a problem of closure. So I have to use this closure in order to make this both will work properly. So this is a genetic programming example, same thing. We are writing first I'm checking initially current population, next population is empty. While termination criteria is not met, first we will perform the crossover. So individual have to be selected. You can use anything, like you can use tournament or roulette wheel, or you can go for a random one. Then this is only for performing the crossover, selecting the fitness and doing the mating. Mutation. If this particular required mutation, whatever the output I got from the set of population is not up to the mark, so I have to mutate in order to make it more flexible and efficient. Then perform reproduction. So while if this particular size is not available, I have to increase the size, and this is replacement. So current population equal to next population. So this is a complete part, and next population will be empty. So current will be overlapped with the next population. Now, what are the values? Fitness appropriate, proportionate reproduction fraction, crossover fraction, mutation fraction, number of individuals in the population. So these are the constant which we are going to use. So this is a complete Lisp programming. So this will help you to know how the genetic programming will be. Thank you.